This video is going to run through the lab calculations for your virtual lab that you watched online. You should have 3 data points that may or may not be the same as these, but you can do the calculations I'm going to with the sample data that you have. And you really only need the mass of the container, the mass of everything before you heat, and then your very last mass measurements. You may have taken more in between, or in the lab they may have done more in between, but the last one is the one where all of the water is removed, and so that's the one that we're going to go with. So essentially what we're trying to do is figure out the formula for CuSO4 dot something H2O, and we want to know what goes in here. And so this is actually a ratio of the particles of water to the particles of copper sulfate. So if we know moles of H2O and we know moles of CuSO4, we can divide those and the answer is that number. So what we're trying to get to is moles of both water and copper sulfate, and that's what these questions are going to help us do. So the initial mass of the hydrate is really just how much you started with before you heated minus the container. So if I call this A and this is B and this is C, I'm really just going to do B minus A here. All the stuff minus the container. So I'll do my 3905 grams minus my 3303 grams. And in my case, that looks like it's going to be 6.02 grams of hydrate. Now, that might be a little more than the value that you're working with. I think the lab suggested 3 to 5 grams. So these all could be a little bit higher than what you've got. Now, we want to know how much water was lost. Well, that's just the difference between everything before we heated it and everything after we heated, because the only difference before and after heating is that we got rid of the water because of heating it. So if I subtract B and C, that will tell me the mass of the water. So 3905 minus 3685, that's going to be, in my case, looks like about 2.2 grams. So that's helpful, but we don't want the mass of the water, we want moles of water, because we actually want moles of both of these things. So I'm going to take my answer from question 2 and turn it into moles. So grams of water into moles of water. We know that we're going to go from grams to moles. We know that moles are in the question somewhere, so that makes it one step. Starting stuff goes on the bottom, just like always. Ending stuff goes on the top. We know that the number that goes with the mole in the conversion is always 1. It's either the mass of 1 mole or the number of items in 1 mole, but the 1 always goes with the mole. And then we need to find the molar mass of water. That's what goes down here. We're not copying this amount. We're putting how heavy 1 mole is. So we know that if we add up an H and an H and an O, 1.01, 1.01, and 16 off the periodic table, we get 18.02 grams. That's what's going down here. And so if I take a second and divide that, 2.2 divided by 18.02, you obviously use your numbers. I get 0.122 moles. Now, don't stop at 1 decimal place here. That's going to give you horrible numbers for your percent error. Also, if you have a 0, like say you have 0.01357 moles, don't say that this is 3 sig figs, because the zeros up front never count. So you want to go out here, and so you would call that 0.0136. So don't chop this off to 1 sig fig, because then that's going to make your answers really bad. So this is one of the things we need. That's the moles of water. Now we need to repeat this process and get the moles of just the CuSO4, which is called the anhydrous salt. Salt because it's ionic, anhydrous because the water's not with it anymore. So the amount of the stuff with no water is just this ending part minus the mass of the container. So this is the dry stuff plus the crucible and the cover. We just want the dry stuff. So we got to take away the mass, the crucible and cover. So that's going to be like C minus A. So 36.85 minus 3303, like that. And what is that? 3.82 in my case. And that's going to be CuSO4. Now, quick note, if you take the mass of this and the mass of your water, it should add up to equal the mass of your hydrate, because those are the only two components. If it doesn't, your math is a little weird somewhere. Now, just like we did with the water, we're going to turn this into moles. We're going to take this answer, 3.82 grams CuSO4, and turn it into moles of CuSO4. And so that's the exact same mathematics as before, except now, since we're using grams of CuSO4, just like before, starting on the bottom, ending on the top, the only difference in this whole dog and pony show right here is that we use the mass of CuSO4 instead of the mass of water. And because I'm such a nice guy, I tell you what it is right there. It's 159.6. So if I do my mass divided by the molar mass, which is going to be the same for all of us, then I get 0.0239. So now I have moles of water and I have moles of copper sulfate. It's time to find the ratio by dividing these two numbers. So you're going to take your answer for 3 divided by your answer for number 5. Just like it said in the little instructions there that I gave you. So that would be 0.122 over 0.0239. Hopefully your water is way bigger than your copper sulfate because you have more waters per 1 copper sulfate. So I get 5.10. 3 significant figures. Now, obviously, you cannot have 0.10 of a water. That doesn't make sense. But realize this is experimental data. There's a little bit of error, and so that works out as close as it can to 5. So I'm going to take this number, and that is the number that goes in my formula that I have up here. That's what I was looking for. So this is like the money question. That's what we're doing. So I'm just going to rewrite that formula. CuSO4 dot, and I'm going to take this answer, whatever you got right here, and put it in. There are 5 waters, according to my data, for every 1 copper sulfate. There's the formula for the hydrate. Now, in order to do the percent error, we actually need to know the right answer. Well, the right answer is supposed to be 5. So when you do your percent error, we always take our measurement, which is the M, minus the accepted value. We're going to divide by the accepted value and multiply by 100. So really all this is the difference between my answer and the right answer. So that's like how wrong I am. And then the rest of this makes it as a percent of the right answer. How far away am I from the right answer as a percentage of the right answer? So we're all going to put 5 here and on the bottom because that's the accepted value. We're all going to multiply by 100. The only thing that's different is that we're each going to have a different measured value. Mine is 5.10. Now, your number might be smaller than 5, and that's okay. You'll get a negative number, but let's go ahead and make it positive because we're going to do absolute value. Because I don't care if your answer is too big or if it's too small. I just want to know how far away is it from the right answer. So I'm going to end up with 0.1 over 5 times 100. And so that's 0.02, and then I multiply by 100, and I get 2.0%. So percent error should always be to 1 decimal place. I don't know why they don't do sig figs there, but it's customary to go out to the tens place. So that's really good, 2% error. Yay for whoever's paper this was. It wasn't my data, it was somebody else's. So if you got less than 5% error, that's awesome. If it's less than 10% error, that's really good. And then the other ones, not so much. But we'll see what happens here, because in the bottom part, they're going to give us some ways that this thing can be messed up, and you're supposed to figure out what happens. Now, don't just be like, well, if you mess it up, then your answer will be off. Well, duh. I mean, that's not super helpful. What we want is, will this error cause my answer to be bigger than 5 or smaller than 5? Is it going to make it bigger than it's supposed to be or smaller? So what you do is you take the error and you follow it through the mathematics to see how it mathematically impacts your answer. So here they're just like, they just didn't heat it long enough. They're just like, whatever, close enough. And so when they mass it, there's still water left in it. So that means this number right here is not as small as it's supposed to be. So making this number bigger actually makes the mass of the water smaller. And so as we go through, you'll see how that's going to mess things up. If I have fewer grams of water, then I'll have fewer moles of water. And remember what we did with the moles of water, we took it down here and put it in this fraction. So if I put a smaller number in the numerator, that makes a smaller number overall. Like if you have 3 out of 10 instead of like 7 out of 10, that's smaller. So putting a smaller number on top will mean my answer is smaller. So it's going to make the answer smaller than it's supposed to be. And you can explain why in a sentence. Don't use an arrow, but write down what I said. Here they're saying, well, okay, so we had to clean this thing, but we didn't really, dry all the water out of it. And so no big deal, right? Well, now you're taking all the H2O out of the hydrate, plus you're going to dry out the H2O that was in the crucible. So you have extra water. If you have more grams of water, then you'll have more moles of water, which means you'll have a bigger number in the numerator, which means your answer is going to be bigger, because it looks like all of this water from the cleaning came from your hydrate when it didn't. So the number's bigger than it's supposed to be. And the last one, so here the situation is, okay, I got it done, yay. Oh no, I'm out of time, the bell rang, and it's too hot, I can't measure it right now. Well, I'll leave it and I'll measure it tomorrow. Well, overnight, it actually absorbs moisture again. So it goes from white and it starts turning a little blue, so you can see that it's adding more and more water. So if you dry it all the way, and then you leave it overnight, it goes back this way. And so like drying it and then waiting is the same as just not drying it all the way. So this is the same exact scenario as part A, where you just didn't get rid of all the water. Or you did, but then you let some come back. So your answer is going to be smaller. So use words to explain that and write that down. And that's the deal for the lab. So hopefully this helps. Sorry it was so confusing. I know it's a little bit easier when you do it yourself, but this should help you. And remember, it's not due until Monday now. So don't stress, like do it, don't put it off, but don't freak out that it's going to be late. Okay, see you guys.